Watch what happens to this character as they walk forward. Between one step and the next, the clothing morphs, the facial features shift, and the colors bleed. The moment those details vanish or change between clips, the audience disconnects. Your hero becomes a different person in every shot, and the story dies. This specific issue, character drift, is the dividing line between amateur AI experimentation and real, viable production work. To eliminate this guesswork, you have to show the AI exactly who your hero is before you animate a single frame. You do that by building a proper character sheet. By the end of this lesson, you will have a locked, composited reference image that gives the AI model a complete 360-degree understanding of your character's shape and proportions. Mastering this character sheet is the mandatory foundation upon which every subsequent frame of your project relies. It replaces luck with structural design. A professional character sheet is a clean image showing your exact character against a neutral background. To give the AI a complete map, you need 4 fixed physical angles: front, left side, right side, and back. You also need a row of key emotional expressions to map the face. Happy, proud, surprised, and sad give the model the references it needs. The immediate instinct for most creators is to type out a prompt, asking the AI for all 8 of these panels at once in a single generated image. Look closely at this multi-panel generation. Across these views, the jacket gains stripes, loses buttons, and the pocket placements move around. Image models cannot hold precise mathematical detail across that many subframes at once. The sheet contradicts itself, and a contradictory reference will ruin your animation. The correct methodology is to force the model to focus on getting exactly one angle perfect at a time. Generate the front view, then the left side, the right side, the back, and the expressions, all as entirely separate, clean tasks. By composing these verified individual images into a single master layout afterward, you guarantee a foundational reference built entirely from correct, non-drifting parts. Before you assemble those parts, you have to verify them. Skipping this manual check is how flawed reference sheets quietly sabotage hours of animation work later on. Explicitly count physical details that define your character. Look at this wireframe. Confirm the exact number of buttons matches across every angle. If the side profile has 4 buttons and the front shows 5, catch it right now. Don't wait until you've animated 10 shots. To ensure those details match perfectly during generation, you must follow 2 strict rules. Rule number 1, lock down your exact trait words and reuse them identically every single time. If you write emerald eyes in one prompt and green eyes in the next, you give the AI permission to wander and invent new features. Pick the exact phrase and never let the vocabulary drift. Rule number 2, restrict your final reference sheet to 3 to 6 clean, high-quality angles. When you push past a handful of views, you force the AI to average out conflicting details, leading to a total collapse in image quality. A minimal, rock-solid reference sheet will always drastically outperform a cluttered, chaotic 10-panel sheet that causes immediate model confusion. Character consistency is a mathematically precise alignment. It is achieved through verified components and strict parameters, not a lucky prompt. With your master sheet completed and verified, you are ready to deploy it into an active production environment and start generating video clips. The operational logic here is entirely straightforward. Feed the AI the specific reference angle that most closely matches your intended camera shot. If your character approaches the camera, you use the front view. If they cross the frame horizontally, you deploy the side view. Watch the result of applying an isolated side view reference to a lateral moving shot. The model has its exact mathematical anchor, moving without any drift. This strict methodology easily scales to major productions. This lineup shows an entire 13-character animated series, locked entirely using this exact process. Because every single character in this production had a verified, composited sheet, they could be dropped straight into video generation with 0 identity loss. Once your reference sheet is built from verified single views and locked terminology, consistency stops being a matter of luck. Your character is now perfectly locked and acting as a flawless anchor. The next step is to take this foundation and design the narrative around it using a storyboard. When you have a character locked in, the temptation is to jump straight into generating shots. But amateurs who generate at random find that their shots don't match. their pacing is off, and the story eventually collapses. Trying to edit a story together after the fact leads to a mountain of discarded clips that never quite fit the narrative you intended. Professionals use a storyboard as a blueprint for the entire video. Once it exists, the actual generation and editing become a matter of assembly rather than guesswork. As the diagram shows, a day spent boarding prevents a week of failed generations. You save time by catching errors on a static image before spending any resources on video rendering. By the end of this module, you will have a fully audited 9-panel contact sheet ready for production. This process requires the locked character reference sheet you built in Section 1. You will need those exact traits to maintain consistency. Storyboarding transforms your workflow into a predictable sequence of steps where every shot has a specific purpose before you even hit generate. To begin, split your story into scenes. For our purposes, a scene is defined as a single location or one continuous moment. Each of those scenes needs to be broken down into exactly 9 smaller moments, which we call beats. A beat is one clear image that carries the action forward: a character arriving, a close-up reaction, or a wide setting shot. Each one represents about 1.5 seconds of screen time. We organize these beats into a 9-panel contact sheet to see framing, angles, and character positions at a glance. This verifies the flow and your directing decisions on paper. To keep characters locked, attach your reference sheet to every panel's prompt. This 9-beat structure provides enough coverage to tell the story with a natural film rhythm, ensuring the scene has enough visual variety to keep the viewer engaged. Generating a consistent board requires one clear, specific instruction for every panel. This is a rich prompt. It identifies the shot type, like a medium or close-up, the character's expression, the setting, and the exact beat of the story. Inside this prompt, you must reuse the exact locked trait words from your character sheet. Vague prompts force the AI to invent new details on its own. If you don't specify the background or the lighting, the model will fill those gaps with inconsistent elements. Precise and repeated language is what keeps the character and the world consistent from the first panel to the 9th. Mastering this prompt syntax allows you to dictate the specific details of every frame, rather than letting the AI lead the design. To stop backgrounds from shifting or inventing themselves, you need to apply the axis rule. This diagram shows the camera bearing. Within a single scene, keep the camera on one axis. You can change shot size or height, but never the bearing. If you suddenly prompt a view down the road, the AI invents a new path, ruining your geometry. Keep your prompts locked to that one bearing unless the story genuinely requires a cut to a completely new angle. This spatial control also helps you time your reveals. If the scene ends with a surprise destination, you can ensure it doesn't appear in the background until the exact beat the script requires it. Following the axis rule ensures your environment remains geographically logical, preventing the visual jarring that occurs when AI-generated worlds shift between shots. Discipline in your prompts applies to everything in the frame. If you establish 5 people at a bus stop in panel 2, you must name and count those same 5 people in every subsequent panel of the scene. Before you move to video, you must perform a slice audit. This means inspecting every panel at full size to catch contradictions before they are animated. Use a checklist for each panel. Check the character is on model, the axis is respected, and counts remain identical. Catching an error here only costs the time it takes to regenerate one image. But if you wait until the scene is animated to find a mistake, you lose the time spent on the entire video render. The result is a complete beat-by-beat blueprint. Your characters are locked, your environment is stable, and your reveals are timed to the narrative. With the structural design of your scene finalized, you have a reliable map for the next stage. In the final section, we will turn these static panels into a finished moving video. You have your character locked. You have your storyboard drawn. Now we bring those static frames into fluid, cinematic motion. The central rule of this phase is strict discipline. Build your video one scene at a time, referencing the blueprint for every step. For every single clip you generate, you feed the model 2 specific items. First, the storyboard panel, which dictates the action. Second, the character reference sheet, which locks in the identity. A common mistake is uploading the character sheet for the first few shots, getting comfortable, and then stopping. Skip the reference, and by scene 5, the character's face and clothing will begin to drift. Attach it to every prompt, and scene 50 will look exactly like scene 1. The same logic applies to the environment. Following the storyboard panel precisely ensures that the geometry of the room and the placement of the actors stay correct from cut to cut. Anchoring your generations to these two static documents is exactly how you turn a disjointed pile of AI generations into a cohesive, seamless piece of film. Let's look at the mechanics of actually locking that character reference into your generation software. In tools like Google Flow or Higgsfield, you don't just drop the image file in. You actively tag the asset by typing an @ symbol, forcing it to hold that identity. Next is angle matching. If a character drives left to right, feed the AI the side view reference. If they pull away, give the software the back view. And if they approach the camera, anchor the prompt with the front-facing profile. Feed the model a front view for a shot showing the back of the character's head, and the AI guesses what that missing geometry looks like, causing the character model to break. Matching the reference angle to the camera angle removes the guesswork entirely, maintaining the illusion of a solid three-dimensional person in a 2D workflow. Even with a locked character, relying purely on text prompts often yields unpredictable, wandering movement. To fix this, we use start and end frames to dictate exact physical paths. The start frame provides the exact beginning position for your character before the movement begins. Your end frame tells the AI exactly where they need to finish. The model then calculates the movement between those two specific points. By setting clear boundaries, you stop rolling the dice and start deliberately directing. If you want to accelerate this process, you can bypass hand prompting each shot by turning on agent mode. Upload 3 things to trigger this: your storyboard, character sheet, and a style prompt. The agent reads the storyboard panels, writes individual prompts for every shot, and generates the full batch of clips in one pass. This automation shifts your role. Instead of performing repetitive data entry for 50 separate shots, you step back and act as a high-level creative curator. Even with locked references and agent automation, AI video will occasionally glitch. An object might flicker, or the camera might land incorrectly. The professional response is not to fight a single bad generation. You generate 3 variations of any critical shot, and you select the cleanest take in the edit. Next comes assembly. Because the shot order was decided during the planning phase, you simply drop your curated clips onto the timeline in the exact sequence of your storyboard. You trim out the weak frames, layer in your voiceover, and drop the volume of the background music so it sits comfortably beneath the narration. Here is a reliable editing technique. Cut the music track to create a half-second of complete silence right before a major reveal. That sudden quiet forces the audience to pay attention, just as the action peaks. Design the board, anchor the character, animate the motion, and cut the timeline. This strict pipeline is a repeatable system that takes an idea and turns it into a consistent, professional film.